Part 3. Multi-factor authentication. Multi-factor authentication or MFA is a security method that requires a user to provide two or more pieces of evidence or factors to prove their identity when logging in. So what's MFA? Well, instead of just using a password, something you know, MFA adds more checks like common factors, that is something you know, password or a PIN, something you have, a phone, smart card or token, something you are, which is fingerprints, face or retina. So, with your password or PIN, that's one combination, you have a token and your fingerprint. Within these three, a combination of at least two is used for an MFA. Real world example, when you log into your bank account, you enter a password, you receive a OTP on your phone. So that's an example of an MFA. Now, how do you implement MFA as a best practice? Well, you first have to decide which systems, application and users require MFA. As a start point, you can start with admin accounts and remote access. But you have to decide which one within your system you want to enable MFA. It should support, the app should be supporting OTP or SMS, hardware token or biometrics. Need to ensure your IAM or SSO tools allow MFA configurations. Apply MFA for external logins, cloud access, financial systems or privilege accounts. Only ask for MFA when risk is higher. You don't want to use it across. Of course, you can, but it has its own cost. So, choose your step 1. Decide which system you want to have an MFA enabled. Inform employees in advance, explain the reason, and provide setup instructions. Allow users to enroll their devices or apps securely on first login. This is how you go about implementing the MFA. Ensure login, recovery, and fallback options work properly. You need to test it before it goes live, and rigorous testing is required. Educate staff on how to use MFA and what to do if their device is lost. Track how many users have successfully enabled and are using MFA. Now, this is a crucial point. You might have teething issues when you start in, and this is where testing how many failed matters more than how many logged in, because that is an issue that you have to fix early on. Create a secure method for emergency access. You would need to have this maybe initially, but eventually the usage of these method or backdoor should go away completely. Yes, you will have emergency cases, but that should be rare. Now, how do you verify MFA is working and accepted? Well, test login from an unmanaged device or external location. It should ask for an MFA. If it is working, it will ask. Generate IAM report to verify MFA is active for high risk or all users. Confirm users have completed setups and have at least one backup method. Attempt login with only a password. Ensure the system blocks it without second factor. You need to test. You're testing whether the system breaks. That's your objective. Configure alert for skipped MFA, failed MFA attempt, or account lockout. A critical aspect of the testing to test whether it's working or not. Ensure logging event shows MFA success failure. Both are important. Failure in specific and factors used. Confirm break glass accounts are reviewed regularly and have proper control. Important to say, check whether the break glass works or not. Test it. Test user identity verification when the MFA devices are locked or lost. Test access with different devices and risk levels to verify dynamic MFA triggers. Ensure logs and MFA usage reports support audits for GDPR, DPDP, SOX, etc., or anything which is relevant to you from a regulation perspective. Align it. For successful MFA rollout, there are a few tips. Start MFA with privileged users and expand gradually. Avoid a big bang approach. Use authenticator apps like Microsoft, Google Authenticator instead of SMS where possible. It's more secure that way. Always offer backup methods, alternative device, emails, or code. Consider going passwordless over time using biometrics or FIDO2 security keys. Next, biometric authentication. Biometric authentication is a security method that uses unique physical or behavioral traits to verify a person's identity. What are the common types of biometrics? Well, most are known: fingerprints, face, iris or retina scan, voice recognition, hand geometry, typing pattern, which is behavioral biometrics. Well, an example: unlocking your phone using your fingerprint or face scan is biometric authentication. It works because your fingerprint or face is unique to you. So that's biometric in real world. Why use biometrics? Well, it is hard to steal or forget, unlike passwords. It's fast and convenient for users. It's good for both physical and digital. It's often used as a second factor in multi-factor authentication. Now, how do you implement biometric authentication? Well, as a checklist, let's go through it. First, you choose areas like device login, app access, time and attendance, or secure rooms. You don't go about implementing biometrics all across unless and until you are something like a defense establishment or critical infrastructure establishment or a super secretive location which requires extremely high level of security, because these are expensive. There are overheads, so you need to balance it out. Use proven tested tools. Example, Apple Face ID, Windows Hello, enterprise grade fingerprint scanner, etc. Ensure biometric tool work within your IAM MFA platforms. It could be Okta, Microsoft Entra, Ping Identity, etc. So on the first part, on tested tool, you need the system to work when it needs to work. The last thing you want is you use it and you are unable to get in and you are in a critical position. Either there is an incident or a breach and you can't get in, you are stuck. If the tool is tested and proven, the chances of misbehaving or funny behavior will be less or eliminated. Never store raw images. Use encrypted template instead and store locally if possible. Inform users and get written consent, especially for GDPR, DPDP, biometric law compliance. This is key now, critical now. As part of the regulation, you need to have a consent in place. In case biometrics fail, offer a secure PIN, password, or an MFA fallback. You don't want to rely on a single mode. But then you need to have a mechanism to track how many times the biometric did not work and people have to go for a secondary method to get in. If the numbers are high, you have to figure out which is not working and why. Fix that. You don't want a situation where the biometric never works and everyone is doing the backdoor entry or an alternative way to come in. the objective is lost. You remember, it is an expensive proposition if it is not working. Train users on how to enroll their biometric data and use it safely. Use biometric only for authentication, not for tracking behavior unless explicitly approved. Ensure software firmware is up to date to avoid vulnerabilities. Ensure biometric data is deleted securely when a user leaves the organization. Let's now check how do you verify whether your biometric authentication is working correctly. On one hand, you have a claim that it's all done, fantastic implementation, but how do you know it is? That's where the checklist would help you. Try logging into a system or device. Biometric should prompt as configured. Verify biometric matches are reliable, wherein you don't have false positives or failed matches. Disable biometrics on a device and test if the fallback is working. Confirm biometric data is encrypted and stored as mathematical templates, not actual image. Check HR or IT systems for user consent logs and policy acknowledgement. Review logs showing successful and failed biometric attempts and device details. The right way to test is to check out how many failed and then investigate why and fix if it is because of the system. Test biometric spoofing. Example, using photo or silicon finger or using vendor guidance. Ideally, all of this should be blocked. Bring in your red team to test it. Bring in the experts who can break this up. Check out at what level it breaks. Eventually, at a particular point, all will break. But check out how easy or how difficult it is. Knowing it helps you to understand the risk that you are having in spite of all of this implementation. It should be within your risk appetite. Talk to your risk manager. You will get to know what is your risk appetite. Check version history or updated logs for biometric devices and software. Part of your patch management, no different here. Verify user biometric data is deleted when employment ends or access is revoked. Next is validate if implementation aligns with the data protection and biometric regulations. Hope this two checklist helps. The first one is how to go about implementing. The second is to check if the implementation was done as intended and if you have achieved the objective. Some tips: use multimodal biometric. Example, fingerprint, face for critical systems. Avoid storing biometric data in cloud unless encrypted and legally approved. Combine biometric with MFA for higher assurance levels. Use behavioral biometric like typing rhythms, mouse movement to detect anomalies silently in the background. Next is single sign-on or SSO. Single sign-on is a login system that lets user access multiple applications with just one set of login credentials, usually one username and password. Instead of logging into each system separately, users log in once and gain access to everything they are allowed to use without logging in again each time. Example, you sign into your corporate email account and now you can also access your file, storage, HR portal, CRM and Teams without logging in again. Now this is a scenario which you already have. Most of the organizations have this in place and use this. So why use SSO? Well, it simplifies login for users. It reduces password fatigue and reuse. It improves productivity, it enhances security when combined with MFA, it centralizes control and auditing for IT teams. Let's now look at how to implement SSO securely. As a best practice, use this as a base reference to start with. Pick a secure and scalable solution. Trusted one, tested one, or highly recommended, or known ones. Configure a central IDP, that is identity provider, that handles authentication and shares user identity with apps. Ensure app supports SAML 2.0, OAuth 2.0, or OpenID Connect for SSO integration. It's important. These are standard protocols. Identify which application will use SSO. Start with high use or high risk apps. Add a strong MFA check at the SSO login page for better security. Ensure that SSO also reflects user roles and permission accurately for each app. That's your backend work. It's your pre-work. Configure limits on for how long users stay signed in and when a re-authentication is needed. You need to define it first in the policy and then technically in the system. Combine with conditional access rules, that is restricts access from unknown device or risky IPs, etc. Educate users on how SSO works and what to do if an SSO login fails. Maintain up-to-date diagrams showing how SSO connects to each system. Start with pilot users and expand to the rest of the organizations gradually. Now, you have implemented. How do you test it? Well, start by testing login to the core system. One login should grant access to all your assigned apps. After SSO login, verify MFA is required and active for sensitive apps or not. Confirm apps are integrated using SAML, OAuth, or OpenID. Ensure IAM or SSO platform logs login attempts. Hence, you have to dig into your log systems to see when you logged in, was there an entry in the system. You need to also check SSO token use and session timeouts. Users should only see apps they are allowed to access based on their role in the group. This will ensure that the mapping is correct. Close browser or wait for timeouts. System should ask for login again. Try accessing an app without proper role mapping. SSO should block this access. Emergency account bypassing SSOs are tightly controlled and monitored. Test your break glass. Ensure login and access data is stored for audit needs. Gather feedback from user and help desk to identify usability or access issue. This you can tie it with your incident management process, wherein anyone not able to get through or having issues, they can record their issues and then you can use that for your analysis. A feedback mechanism. Some tips: start with cloud-based apps and expand it to on-prem systems later. But then that is entirely your organization's call based on the comfort level that the implementer has on. Always use MFA at the SSO login stage. SSO alone isn't secure without it. Maintain a service catalog that maps SSO enabled app to business owners. And monitor login patterns for anomalies or unauthorized behaviors. What is passwordless authentication? Passwordless authentication is a secure way to log in without using a password at all. Instead of remembering or typing a password, users log in using other secure methods like biometric, which is fingerprint, face recognition, security keys like YubiKey or FIDO2 keys, or one-time codes or magic links sent to emails or phones or push notification approvals from a mobile authenticator app. So that's passwordless authentication. The real world example of passwordless authentication, well, you open your laptop and it unlocks with your fingerprint, or you log into your office app by tapping approve on your phone, or no password was typed, that's passwordless login. Now, why use passwordless authentication? Well, no passwords to forget, steal, or reuse, or stronger security than traditional password plus MFA, faster login experience, helps meet compliance and reduces phishing attacks. So, how do you implement passwordless authentication? Well, as a best practice, these are few of the steps, but you can customize it based on your organization's requirement, needs, and regulatory requirements. Starts off by identifying where passwordless makes the most impact. Cloud app, privileged account, remote works, etc. But you have to decide which one it is. Use trusted platforms like Microsoft Entra ID, Okta, Duo Powerless, or Fido, and so on. There are many more in the market, but the one which you trust, you have worked on, that's the thing that you have to pick up based on your comfort level or organization's direction. Support biometrics, hard token based logins. Make sure systems support your chosen method. You don't want a system to be implemented which is not well integrated with your current environment. Now that's going to be a wasteful enterprise. Users should enroll their devices or method in a secure way with identity verification. It's about registering devices or credential securely. Start with specific user groups like admin, remote users, or cloud app users. Allow access only from trusted devices or networks and block from risky locations. Some basic hygiene here. Begin with pilot users. Gather their feedback and expand gradually. Have a secure fallback wherein you can recover for edge cases. Train users on setups, use, and what to do if their device is lost or changed. Maintain clear documentation on setup, recovery, and support process. Now, how do you verify passwordless authentication is working correctly? Well, you start by testing, of course. Test login using biometric, push approval, or FIDO2 keys without being asked for a password. Verify that passwordless logins still satisfy MFA's requirements under compliance standards. Try to log in using only a password. System should ideally reject it or block fallback unless explicitly allowed. Check that enrollment of biometric or keys is done only after verifying the user's identity. Simulate a lost device and test whether the recoveries are working or not. Ensure authentication events are logged, when it is used, what method, what location, when it was used. So logging is critical here. Try logging in from new or risky device. System ideally should block, notify, or request for additional approvals. Confirm that access is blocked from unregistered or unmanaged devices. Any exceptions to the passwordless rules are logged and approved through formal workflow. But define your exceptions early on what conditions. Review if new conditions have occurred where an exception method was used. Review for relevance and document it. This would be critical when analysis are done or audit is reviewed. If they find an exception and not recorded as part of your documentation, you might end up holding a penalty. So, try out all the exceptions that is possible as much as possible in combination. Validate that the passwordless implementation support the ISO 27001, SOC, DPDP Act or other frameworks as needed. Now, tips on how you can go about. Start small. Apply to high value users or app first. Use FIDO2 or WebAuth compliant solutions for strong phishing resistance authentication. Keep fallbacks options tightly controlled and monitored. That is, you don't want a situation where most of them are using fallbacks. If that is there during production, your implementation has gone for a toss. Acceptable when you are in test phase, pre-implementation or pre-implementation in production environment. You can fine tune it, refine it and get it to zero if possible. But if in production you have this situation and the numbers increase, it's a serious indicator of a flawed implementation. Consider combining passwordless with zero trust principles for maximum protection. So we are now into the next one, which is authorization. Authorization determines what resource a verified identity can access, governed by role-based rules, time of the day restriction, or conditional access policies. So, what are role-based rules? Well, role-based rules are used to control who can access what in a system based on the person's job role in the organization. See, instead of giving permission to each person one by one, we create roles like HR manager, finance analyst, IT admin, sales executive, etc. Each role has a set of permissions assigned to it, like access to specific files, apps, or systems. Then users are assigned to roles and they automatically get the required right access. So, real time example, imagine a company uses a shared drive. Everyone in HR can see employee records, everyone in finance can access budget, IT admin can manage all user accounts. Instead of setting access manually for every individual you create a HR role, give access to employee files. A finance role gives access to financial systems. An IT admin role gives full control to system settings only. So, when a new employee joins HR, you assign them the HR role and they automatically get the right access. So, it is not a free for all kind of access. You have restricted it. So, why role based rules are useful? Well, it is simple to manage. You just need to manage roles, not individual permissions. It's secure because it prevents over permission, giving people more access than they need. It's efficient because it's fast onboarding and offboarding. It's audit friendly, easy to prove who has access to what and why. Let's look at the flow. The role based rules, how it works? Well, starts by defining roles. Example, salesperson, HR manager, support agent, etc. Assign permissions to the roles. What systems or data should each role be allowed to use? Align users to the role. And each user gets the access they need based on their job. Now, post that, review the roles regularly and make sure the permission still makes sense and adjust when the job changes. Next is time of the day restriction rule. Time of the day restriction rules are rules that control when users are allowed to access systems or data based on the time of the day. These rules help make sure that user can only log in or use certain application during approved hours such as office hours or shift timings. As an example, a contractor working night shift is allowed access only from 7 p.m. to 7 a.m. An HR employee can access the payroll system only from 9 a.m. and 6 p.m. Monday to Friday. Hence, if someone tries to log in outside their allowed access time, access will be blocked or flagged as suspicious. So that's the example of time of the day restriction rules. So why use a time of the day restriction? Well, it improves security. It reduces the risk of unauthorized access at odd hours, limits insider threat. It blocks access when users are not expected to work. It helps with compliance, that is, enforces access policies and usage patterns. Supports shift based teams. It grants access based on scheduled working hours. Now let's look at how time of the day restriction works. First, you define your working hours for each user or group. Then you set up rules in the IAM or access system that blocks access outside those hours. Then you apply rules to roles or individual. Example, only apply to vendors or admins. Then you monitor activity for attempts outside allowed time windows. Then you allow exceptions only with approval. So there could be an exception. If it is an exception, then with right review and approvals, you can get through. Example, urgent maintenance or travel. Example, allow login to the HR portal only between 8 a.m. and 6 p.m. Monday to Friday and block access to all other times. So that's a sample rule. I hope this helps in better understanding of time of the day restrictions. Next we come on to conditional access policy rules. What are those? Conditional access policy rules are smart rules that allow or block access based on certain conditions like who is trying to log in, where they are logging from, what devices they are using, what time it is, what app they want to use, how risky the login looks. Think of it like a digital security guard that asks, should I allow this person in under these conditions? Real life example, a manager can access the company dashboard only from a company laptop. Yes, allowed. An employee logging in from a foreign country is asked for extra MFA or verification. Allowed. But if someone tries to access sensitive data outside working hours, blocked. That's one case. Why use conditional access? Well, it increases security by adapting to real time risk. It supports zero trust, which is about never trust, always verify. It meets compliance requirement for secure access control. It reduces unnecessary friction by allowing safe access without extra step. What conditions can be used? Well, you can use at user or group wherein apply rules only to admin or vendors. You can block access from risky countries, allow access only from company laptops, extra checks for financial systems, allowing logging only during working hours, and trigger MFA if login looks suspicious. So here different conditions were on user or groups, location, device states, app being accessed, time of the day, and risk levels. So these are the different conditions which can be used. You can think through which works for you. If all of them work, then you can use a combination of logics for your systems, and you can choose the system to use which logic works for which type of system or access. So how it works? Well, users try to sign in. IAM system checks condition who, where, device, time, etc. If rules are satisfied, access is granted. If something looks risky, MFA required or access are blocked. And all actions are logged for audit and monitoring. Example, if an employee logs in from a trusted device in India during office hour, it allows access without MFA. But if the same person logs in from an unknown device or from outside India, it requires MFA or a blocked access is noticed. Provisioning and deprovisioning. Automated process to create, modify, disable, or delete accounts across systems. Its integration with HRMS, directories, and cloud platform is common. That's your provisioning and deprovisioning. Now, let's break it. What's provisioning? Provisioning means setting up access for a new user, whether it's employee, vendor, contractor. When they join the organization, it includes creating their user ID, giving them email, application access, shared folders, or assigning them to the right role or group, making sure they get what they need to start working on day one. Example, when a new sales executive joins, provisioning gives them access to Outlook, CRM, Teams, and shared sales document. What's deprovisioning? Well, deprovisioning means removing access when someone leaves the company or no longer needs certain systems. It involves disabling their user ID, blocking access to emails, files, and apps, or reclaiming their licenses or devices, or archiving or transferring their data. Example, when an intern completes their assignment, deprovisioning ensures their access is removed immediately to prevent any misuse. So that's deprovisioning. So, why are provisioning and deprovisioning important? Well, it ensures smooth onboarding and exit experience. It reduces manual error and IT workload. It helps meet compliance, whether it is GDPR, ISO 27001, SOX, etc. And it helps protect data and systems from unauthorized access. Let's look at the flow, how it works. Well, example, HRMS like the SAP Workday is the source of truth. When HR adds or updates an employee record, the IAM system detects the change. Then provisions or deprovision is automatically triggered. Example, HR updates a record to resign, IAM disables all access the same day. So, how directory integration works? Well, directory stores user credential, roles, and groups. IAM tool connects to directories to create or disable user accounts, assigns group memberships, syncs user information across systems. Example, new user is added to finance group in Active Directory, they get access to finance app automatically. So, how cloud platform integration works? Whether it is Microsoft 365, AWS, Salesforce, etc. Well, IAM connect to cloud service using API or connectors. When provisioning IAM creates user account in those platforms, then it assigns licenses, apps, and roles. When deprovisioning, IAM suspends or deletes accounts, revokes token access tokens, and credentials. Example, IAM deprovisioning a user from Salesforce and Google Drive in one click. So people who have used it would now be able to correlate. So that's your provisioning and deprovisioning. In summary, from an HRM component perspective, it triggers action when user joins, moves, or leaves. From an AD, it stores and syncs user ID, roles, and groups. From a cloud perspective, platform perspective, it grants or removes app access and licenses. Now let's look at a checklist for provisioning and deprovisioning. From a provisioning perspective, it triggers from HRM. This ensures IAM system receives joiner data from HR. Then it generates ID on Active Directory or IAM system with default attributes. Then it maps users to appropriate job role access group based on department or job function. Then it creates and assigns emails, Teams, Slack, share drives, calendar, etc. Then it provides access to business application, whether it is ERM, CRM, HR, etc. via IAM or SSO integration. Then it enables VPN, Wi-Fi, desktop, laptop credentials, and endpoint security policies. Then it enrolls users in MFA and enforces password complexity and expiration rules. Then it sends onboarding email or welcome kit with credential, instruction, and support contacts, and captures and retain audit trails of account creation and system access. Does it sound similar? Something which you experienced when you joined the organization? So that's provisioning. Now let's look at deprovisioning. In this, a trigger is from the HR, that is a leaver event. The IA system in this case receives termination or exit notice from HRMS. It immediately disables account in Active Directory and IAM. It removes access to all enterprise system and apps, whether it is CRM, ERP, email, etc. It recovers the software license, the device, the token, the VPN access, and cloud storage. It forwards mailboxes, reassigns documents, or archive data per retention policy. It blocks networks, Wi Fi, and VPN access. It wipes out any mobile laptop remotely if needed. It ensures all revocation steps are logged for audit and compliance purposes. It validates that all access has been removed and accounts are closed. And it confirms deactivation when with manager and security team. Now, does this sound similar? If you have experienced an exit, you would have experienced the deprovision aspect of it. I hope this gives you a clearer thought process on how the flow works. Do note this is again, you might have certain additional steps to it or your lesser steps, but generally this is the top view of how the provisioning and the deprovisioning works on ground. What can go wrong in provisioning and what would be the impact? Well, if there is delay in provisioning access, new employee can't start work on time, leading to productivity loss and poor onboarding experience. The next issue is when if a wrong role or permissions are assigned to the user, well, user get access to unauthorized data or systems, causing security and compliance risk. If the access are not granted to all needed system, in that case, an employee is unable to complete tasks efficiently, affecting operational timelines and morale. If it is about manually provisioning errors, well, it increases the chance of misconfiguration, duplicate accounts, or gaps in audit trails. If there is no approval workflow for access, user may receive access without managerial oversight, leading to over provisioning and audit issues. Well, when it's lack of MFA setup during provisioning, well, user account may become vulnerable to credential theft, phishing, or brute force attack. If it's about inconsistent provisioning across system, well, in that case, mismatch between directory, cloud, local system can cause integration failure and access confusion. Does this resonate with you? Have you experienced this either during provisioning or any other situations where you would have noticed this? The next is what can go wrong in deprovisioning and what would be their impact. Think through. If the access is not revoked after exit, former employee or contractors can still log in. Major insider threat risk. If the cloud SaaS access are not removed, sensitive data remains accessible through external or personal device. If orphaned account in directories or apps, if that's the situation, it increases the attack surface, especially if the accounts are privileged. If there is delay in reprovisioning process, windows of opportunity for data theft or sabotage before access is terminated. There is a failure to reassign data or responsibilities, it can lead to data loss, missed tasks, or disruption in team operations. There is a lack of audit trail for deactivation. Well, it would be difficult to prove access removal in audit, leading to compliance gap. From a licensing and resource wastage, idle account continue to consume software license or cloud resources, increasing their cost. In summary, from a security risk perspective, the impact is unauthorized access, insider threat, privilege escalation. Failure to meet SOX or GDPR or DPDP or ISO 27001 requirement is a compliance risk. Delay in user productivity, project delivery issues is an operational risk. Wasted licenses, audit fines, or breach remediation cost is a financial impact. Poor onboarding, offboarding experience, or regulatory scrutiny is a reputational damage. So these are the impacts from a provisioning and deprovisioning perspective. Now comes to how can we prevent it? What are our potential opportunities? Starting off with, you can automate provisioning and deprovisioning with IAM tools. You can integrate IAM with HRMS, directories, and cloud apps. You can enforce role based access and approval workflow. You can schedule regular access reviews and orphan account audits. Log all access changes and make them audit ready, or conduct onboarding and offboarding quality checks. In summary, provisioning risk, well, what can go wrong? Incorrect or delayed access setup for new joiners, reducing productivity, increasing IT workload, or creating security and audit risk. If the from excessive access perspective, well, in such cases, user can receive more access than needed due to the role mismapping or lack of approval. The impact is violating the least privilege, increases insider threat and exposure and audit violations. If there is a lack of MFA setup, well, accounts are left vulnerable to attack due to missing multi-factor authentication. Thereby, there is a high risk of credential theft, unauthorized access, and reputational loss. From a deprovisioning failure perspective, well, access are not removed when user leaves the organization. It can lead to orphaned account, data breaches, and non-compliance with regulations. No data transfer during exit. Well, it can departing user data is not reassigned to or archived. Well, it can cause operational disruption, loss of critical information, and missed handovers. No visibility or audit logs. Well, can access change not tracked or reported? Well, it's difficult to prove compliance, detect misuse, or respond to incidents. From a licensing wastage perspective, an inactive or duplicate account continue consuming softwares or cloud licenses, thereby increasing the IT spend unnecessary with poor return on investment on tools. Access certification and reviews. Routine audit to review and validate access right, ensuring alignment with policies and regulatory mandates. So, what does routine audit to review and validate access rights mean? Well, it means regularly checking who has access to what and making sure that access is still correct and necessary. Just like you do regular inventory checks in a store, access audits are done to see if people still need the system or data they can access. It's also done to remove access if someone changed roles or left the company. It's also done to spot if anyone has too much access or access to things they shouldn't. Why is it important? Well, it prevents insider threats, no excessive or outdated access. It improves accountability. That is, every access has a clear business reason. It supports compliance, which is proves to auditors that access is well managed. It reduces security risk. It stops unauthorized access. So, how it is usually done? Well, IAM system or IT teams create a list of who has access to which system, apps, or files. This list is sent to the respective manager or data owner. The manager checks, is this person still in the team? Do they still need this access? Do they have more access than they should? The manager approves or updates or revokes the access, and all the decisions are logged for audit records. Any access that is not approved is removed. I hope this flow makes it clear how this works. So, how often should it be done? Well, high risk system every 3 to 6 months. Other systems could be annual, semi annually, and or after major changes, immediate. That's a thumb rule as a best practice. Example, John was in the finance team but moved to HR last month. During the access review, his old manager sees that John still has access to the budgeting system. The manager marks it as no longer needed. The IAM removes his access and the change is logged in. Problem is avoided, access is now correct, and it's now audit ready. Next is identity repositories. Database like LDAP or Active Directory that store user credential, attributes, and entitlements. That's the focus. So, what is identity repository? Well, identity repositories are like secure storage systems where all the information about users in an organization is kept. This includes username, password encrypted, job roles, department, access right, email address, group membership. These repositories are used by IAM system to verify who a user is and decides what they can access. Example, think of an identity repository like a staff directory at the front desk of a company. When someone arrives, the receptionist checks the directory to confirm who they are and what area they are allowed to enter. Similarly, IA system checks the identity repository before allowing user to access any system. Common example, Active Directory. That's the repository. Purpose, most commonly used in Windows environment to store users and group information. Next is LDAP, which is Lightweight Directory Access Protocol. It's a protocol used to access identity data in many systems. Next is Cloud Directory like Azure AD or Okta Universal Directory. It's used for cloud based identity storage and access control. Why identity repository matters? Well, it enables central control of access. It provides a single source of truth for user identity data. It supports single sign on, MFA, and account provisioning. It helps system know who you are. Let's look at credentials. Credential is who you are and how you prove it. Credentials are things a person uses to prove their identity when logging in. Example of credentials: fingerprint or face scan, smart card or security token, one time password, username password. These are examples. What are attributes? It's details about you. Attributes are pieces of information about a user that describes who they are. Example: job titles: manager, analyst; employment type: full time, contractor; location: which location you are from; name, department, whether it's finance, HR, and so on. So those are attributes. Do note, this is repository. This is credentials. And now we are attributes. So difference between credentials, it's you, your individual, and what you have to prove you are. And next is attributes, the features around associated with you. What's entitlement? It's what you are allowed to do with your credentials, with your attributes. What are your entitlements? Entitlements are permissions or access right a user has within a system. Example of entitlements? Well, permission to approve leave request, ability to manage user accounts, right to access a database or application, or access to view or edit a report. Think of entitlement like the keys you are given inside a building. Each one opens a specific door based on your job. Summary: credential is proof who you are. Attribute is an information about you. Entitlement is what you are allowed to access. Real world example: credential is username, password, or your fingerprint. Attribute is your job title, your manager, which city, and so on. And your entitlement is you can view a payroll or access a SAP. Hope this helps you get a perspective on these three terms on credential, attributes, and entitlements. Let's now look at the architecture and model. It has four components: federated IAM, zero trust IAM, cloud IAM, and centralized IAM. Centralized IAM. A single IAM system governs all identities and access policies across the organization, ensuring uniformity and control. So, what is centralized IAM? Well, centralized IAM means managing all user identities, roles, and access permissions from one central system or platform instead of separately in each application or system. It acts as a single control point to create and manage user accounts, assign roles and permissions, enforce policies like MFA or password rules, or audit access across systems. The key components include identity provider or IDP, which manages authentication. Example: Azure AD or Okta. Second is policy engine, which is about enforcing access rules, which is RBAC, MFA, conditional access, etc. Next is directory services. It stores user credentials and roles. Next is connectors or APIs, which is linking the IAM with HRMS, cloud apps, on-prem systems. Or next is audit and reporting module. It tracks who accessed what, when, and how. Benefits of a centralized IAM? Well, it's a single source of truth. All user identities and roles are managed in one place. It improves security. It's consistent policies like MFA, password rules, and access reviews. It's faster for onboarding and offboarding. wherein the users get access immediately upon joining and lose it instantly when leaving. It's better for compliance. It's easy to show auditors how access is managed and reviewed. It's helps simplified user experience, wherein the user logs in once, which is SSO, and access everything they need. And it's scalable. It supports large organizations and thousands of users and systems. Challenges? Yes, there are few. Integration complexity, wherein older legacy apps or system may not support the integration easily. A potential single point of failure, that is, if the central IAM system goes down, access to all systems may be impacted. The initial cost and effort are high. It requires a lot of planning, migration, and sometimes even new tools or licenses. There is a chance of over centralization risk. There is too much access control in one place can be risky if not properly governed. And role explosion, wherein without proper design, too many roles can make management difficult. So that's some of the challenges with the centralized IAM. So use cases where centralized IAM works best. Well, organization needing to comply with SOX, GDPR, DPDP Act, or IS 27001 are cases where this is used. Or businesses migrating to zero trust and needing consistent access control. Or companies with high employee turnover or third party contractors. Or large enterprises with hybrid environment, wherein you have cloud as well as on prem. Let's compare with centralized and decentralized IAM. From an identity management perspective, centralized IAM manages from a single IAM platform or directory, whereas decentralized, each system or department manage their own. From a control point perspective, in centralized, one central authority controls all identity. With decentralized, you have multiple control points or app level ownership. From an integration perspective, it helps to integrate all systems through connectors or APIs. When it is decentralized, independent identity stores with little with or no integration. From a user experience perspective, it's consistent long login experience, unified credentials. Decentralized, it's inconsistent. From a security policy perspective, policy apply uniformly across apps, which is not the case when it is decentralized and it can vary. From a scalability perspective, centralized IAM is highly scalable with centralized rules and access designs. Wherein it's decentralized, it's very difficult, it's harder to scale up. From a governance and compliance perspective, it is easier to enforce audits and compliance. In decentralized, it is difficult. From provisioning and provisioning perspective, centralized provides faster provisioning. You can automate it better. With decentralized, it's a challenge. Failure impact, yes. In this case, there is a high impact if the centralized system goes down. That's an advantage in a decentralized, wherein one failure might impact a very small area or only that area which it controls. So that's one positive aspect from a decentralized one. And it's from a suitability perspective, centralized is suitable for large organization or regulated industry or where the expectation is to have a zero trust. Decentralized is fitting for small businesses or loosely federated teams or startups. Common tool examples in centralized, you have Azure, AD, Okta, Ping Identity, SailPoints, etc. Decentralized, you have many legacy systems, specific app-based database or local ADs. Let's look at federated IAM. It allows users to use the same identity across different domains, leveraging trust relationship between identity provider and service provider. So what it is? Well, federated IAM allows user to access system across multiple organizations or domain using a single set of login credentials without creating a separate account for each system. It builds trust between two or more organizations. So users can authenticate with their own organization and still access external service securely and seamlessly. So that's with federated. How does it work? Well, analogy, if you look at it, imagine you are an employee at a company A and you visit a partner portal of company B. You log in using your company A's credential and access company B's service. You don't need a separate username and password for company B. So how it works? Well, it uses identity federation standards like the SAML, that is Security Assertion Markup Language, or OT 2.0, or OIDC, or Open ID Connect. What's the basic component of federated IE? There are three. One is identity provider. This is the user's home organization that verifies the identity. The service provider, the external application or system the user wants to access. And trust relationship. The service provider trusts the identity provider to authenticate the user correctly. So that's with the federated IAM, the three components. How does the flow work? Well, user want to access a partner's app, the service providers. Service provider redirect to user's identity provider for authentication. The identity provider verifies the user and sends a security token assertion, and the service provider accepts the token and grant the access. You go to a website, who's your service provider, it would not authenticate. It would send the request to the to the identity provider, which is a separate organization, which is the organization you believe you are part of. And if your organization authenticates, it will just grant the access. It's not going to do a separate validation. So that's a federated access. Now, where federated IAM are commonly used? Well, example, accessing cloud services like Google, Workspace, Salesforce, AWS, or B2B collaboration, that is vendors, partners, contractors, or higher education systems, students from different university accessing shared platform. These are some of the cases. Now, what is the benefit of a federated IAM? Well, uh, user use their own corporate credential to access external services. Then there is no need to remember multiple username and password. Authentication remains with the trusted source. Easily onboard partners, suppliers, or academic collaborators, and avoid managing multiple identities for the same person. That's the benefit. Now, what are the challenges? Well, uh, it requires agreement, configuration, and compatible standards between the organization, whether it is identity provider and the service provider. They need to trust each other, and that requires a complex set of agreements, configuration, and so on. Needs careful control of who is allowed to federate and under what terms. Example, you might a particular web page of your service provider will grant you access if your organization is identity provider has authenticated, but the same website might have certain sections which can only be accessed if you have an act if you are authenticated by that portal. So it could be a case wherein certain parts are federated. Okay, service provider rely on external IDP's authentication decision. So in this case, in a federated system, the one which is providing you the resource need not authenticate. They would depend on the service provider to provide it. They will rely on external identity providers. Do note, a misconfigured or intercepted token can pose a risk if not handled carefully. Now that's something which this scenario would cause if not handled. They must ensure both parties meet the legal, privacy, and audit requirements. So, if you are an organization which requires certain level of complex regulation alignment, the moment you have a federated system against with a provider, they would also need to comply with you. Otherwise, you become non-compliant because you are getting a service or resources. So that's the complexity. Now, when to use federated IAM? Well, you offer, if you are offering services that needs to be accessed by multiple customer organization, or you need to support secure third party access without managing every external user manually, or you want to reduce the password fatigue and enable SSO across platform, or you collaborate with external vendor partners or academic institution. Do note, academic institution comes regularly here because they prefer to have a federated way of authentication. Okay. Now, a comparison between centralized, decentralized, and federated. We looked at centralized and decentralized earlier in comparison. If we add federated, in federated, multiple trusted identity providers, the source. From a control authority perspective, it's a shared trust model between IDP and SP. IDP is the identity provider, SP is the service provider. From a user experience perspective, it is smooth across domain, accessing using home credentials. It's easy. From an integration perspective, external B2B, SaaS, university or vendor ecosystem. That's how the integration has not only been seen. From a policy consistency perspective, moderate depending on the federated agreement. It is best for cross organization collaboration or partner vendor access. The authentication method in this is standards based, which is SAML, OIDC, or OAuth. Scalability, high enables access at scale without account duplication. It's scalable basically. From a security consideration perspective, requires strict token handling and federation governance. It's a big challenge when you deal with federated one. But then, because it is smooth, it's found to be more useful. Common use case, well, partner portal, cloud apps, academic resources handling and sharing. Hope this gives you a perspective between each of the three. Let's look at authentication method of security assertion markup language. What it is? Well, SAML is a secure way to exchange user login information between two systems, usually between an identity provider like your company login system and a service provider like your Salesforce or Dropbox. In simple explanation, think SML like a digital passport. You log in at your home base and SML sends a secure message to another system saying this person is verified, let them in. It's used for single sign on, logging into external app using corporate credentials, common in B2B or cloud integration. It's XML based format and often used in browser based access. Let's look at OAuth 2.0. OAuth 2.0 is a secure authorization protocol. It allows a user to give an application limited access to their data without sharing their password. Think of OAuth like giving someone a room key card instead of your house key. The key only works for one room, example calendar access, and only for short time. It's used for letting apps access your info, example Google Calendar, LinkedIn, Facebook, login, etc. It's also used for mobile app authorization. It's used for delegating access, like a travel app accessing your email calendar. That's OAuth. OAuth is about authorization, not identity. It doesn't confirm who you are, it just gives you permission. That's an important differentiator between OAuth and SAML. Now let's look at OIDC or Open ID Connect. OIDC is an identity layer built on top of OAuth. It adds authentication. So now the application knows who you are, not just what you are allowed to access. OID is like an auth plus your ID card. You log in using a trusted identity provider and the app knows who you are, that you are logged in safely, what you are allowed to do. It's used for social login, sign in with Google, Facebook, etc. That's OIDC. It's used for mobile and cloud app authentication. It's used for web app that needs both identity and access. In comparison, SAML is used for authentication. OAuth is used for authorization. OpenID OIDC is used for authentication and authorization. Format for SAML is XML based. OAuth is JSON and REST. OID or OIDC is JSON, REST, and ID tokens. Use case: SAML is SOC based. Auth is granting limited data access. And OIDC is logging with identity and access. From a mobile support perspective, Auth and OIDC are strong mobile support, whereas SAML is weak. SAML is built on custom XML standards. OAuth is built on OAuth 2, and OIDC is OAuth 2 plus an identity layer is added. We have now reached end of part 3. I'd like to thank you for taking this time out, investing this much of your precious time into the video. So we will pause here, think through on what we have learned, take notes. You can revisit the video again if there are certain aspects or checklists that you would need to work on your space. To comment if there is anything specific that you think needs clarification or any ideas that you think are missed out in this. Happy to take note and add on to the videos later on. So this is your host Savit Vittal Salian. See you in part 4. Namaskar.